Hey engineers, today I wanted to ask you a question. Are the timed loops any good on Windows? So, timed loop is a structure designed to be used on a real-time operating system in LabVIEW. And well, if it's designed for a real-time operating system, and since Windows is not a real-time operating system, can I really use it on Windows, and do I have any benefits in doing that? Well, you can use timed loops on Windows, and there is a lot of benefits of using timed loops on Windows. Well, the only thing that you need to remember is Windows is not a real-time operating system, and if you use timed loops, it will still not be a real-time operating system. But most of the other benefits of using timed loops still apply. So let me show you quickly an application that I have created with two timed loops. So this code is quite simple. It's just to show you that you can use timed loops on a Windows operating system, and you still get the benefits of using the timed loops. So to access timed loops, you need to go to Programming Palette and then Structures and Timed Structures. So you have two types of timed loops that you can use. There is a timed loop and there is a timed sequence. The difference between timed loop and a timed sequence is quite small. So with a timed loop, on every tick of the clock that you define, you get one iteration of the loop. With time sequence, on every one clock tick, you move into the second and third, etc. part of the sequence structure. There is also 6 other functions that are related to controlling the timed structures, to controlling the timed loops. And those functions are create timing source, fire software trigger timing source, clear timing source. Then you can also synchronize timed structures. You can stop them, that's like aborting them, and you can build a timing source hierarchy. I will not go through all of those functions here. I will just show you an example of using 2 of those. So first of all, I have created a timing source for my 2 timed loops. It's the same timing source, so essentially that means that both of my timed loops will execute with the same clock, and it's a software clock. I will show you in just a second what that means. And then I will use fire software trigger timing source. This is a function which I will use to send essentially a rising edge on my clock. And then the third function is stop timed source. And this function I will use to abort the execution of my timed loops. Okay, and I have added those 3 functions in a simple application like this. So here I have configured the timing source, and I wire it as the input timing source for my timed loop. Here on the input node, as you can see, I have wired the source name, and that's the source of the timing signal, and the structure name. Source name is used essentially to clock the execution of my loops, and then the structure name is used to abort them at the end of the execution. And this is, however, not all of the functions that you can use for your timed loops. You can also define a period of your timed loop. You can define the priority of the execution. This is most important for having multiple timed loops in your operating system running at the same time, because all of the timed loops that you will run in your LabVIEW application will have Windows priority between high and time critical. So they are very high in the priority of Windows, and if you want to define also a priority between the timed loops themselves, you can do it with the number wired here. And then the third thing that is easily available is the processor that you want to use. So if you have a multi-core machine, you can also put a specific loop on a specific core of your machine. And thanks to this, you can optimize the performance of your application. There is also different things available to you. Under a left click, you can define all of those other inputs. And then on the inside of the timed loop, Again, we will not go through everything, but on the inside of the time loop, you have something which is called the output node. And the output node can give you a lot of information useful for debugging or benchmarking the execution of your application. So in this simple example, I am creating a timing source. I am wiring this timing source as the input to the source name on the input node. As you can see, both of the loops are using the same input. And then when I press trigger, this trigger means essentially using this function of firing software trigger timing source. And I'm firing this timing source, meaning that these loops should execute once. And once they finish executing once, essentially they are waiting for another edge. And this is simulated, of course, but you can also define hardware clock. You can use a clock from DACMX tasks. So there is a lot of different options that you can use here, and the timed loop is very powerful when it comes to this. And then I have also defined the name of my loops, and the name is used in the stop case of the event structure, and the stop case essentially just aborts both of the timed loops. So when I run this application, you will see that it reacts to trigger and only to the trigger. So it doesn't execute with the DT that is defined here as the period. It is executing when I send the software trigger on my clock edges. So this is a very simple way how you can write an application to react to some other things in the system. You can create your own clocks. Also, of course, you can define the DT, and if you just wire a normal clock here at the input, so you do not specify software trigger edges, let's say, then this DT will actually control the time of your loop. This loop is not designed to run faster than a normal loop. It will actually execute slower than let's say a for loop or a while loop, but it's designed for you to be able to easily control all of the aspects of the execution. So there you still get the benefits of using timed loops on Windows operating system, and I strongly recommend for you to use them if you want to have better control over how your execution is going on your processors in your machine. And also if you easily want to access some debugging information about the execution speed of your application, timed loops are definitely for you. And for more information about timed loops, please refer to the additional links that I posted under the movie. Thanks.